We are live. How is it going, guys? How is it going? Looks like we don't have very many viewers. Uh oh. I guess last night was a massive party in which everyone in the entire world decided to go to. Coronavirus. Stayed up late till 3 or 4 a.m. But let's go through the DI. So, in last night's lesson, we talked about the idea of a rational equation. And we said in a rational equation, the goal is to eliminate the denominator. If we can eliminate the denominator, then it turns into all the other equations that we already know of. And we already know how to solve those other equations. The way that we eliminate what's in the denominator is going to be by multiplying, right? Because something that's in the denominator is division. So therefore, multiplying, it's going to get us out of the denominator. So going through that, let's look at this first one. We have 3x minus 1 over x squared plus 1, and that equals 1. So to get the x squared plus 1 out of the denominator, we're going to multiply everything by x squared plus 1. So that's going to cancel out. So then we get 3x minus 1 equals x squared plus 1. So now what we want to do is we want to solve for x. And so we're going to minus 3x. We're going to add 1. And so I'm going to get 0 equals x squared minus 3x plus 2. Now it's quadratic. That's the reason why I'm doing this. On a quadratic equation, you want to set it equal to 0. You want to get it all by itself. So the 0, isolate it. Because we're going to use the zero product principle, hopefully. Let's see if this does factor. And so this will factor into x minus 2 and x minus 1. So therefore, x equals 2 and positive 1. Now with rational equations, because it does have that quote-unquote domain restriction, we have to test these, and we just have to make sure we're not dividing by 0. So if we're looking at the original, if I plug in positive 2, that gives me 5. If I plug in positive 1, that gives me 2. Okay. Doesn't divide by 0. So those are going to be solutions. Any comments or questions on that one? Okay, let's look at number 2. So we have 1 over x plus 3 plus 1 over x minus 3, and that's going to equal x squared minus 3x. And then this x squared minus 9, I actually want to factor that. So I'm going to say that that's x plus 3 and x minus 3. So for us to be able to get rid of the denominator, we need to multiply by what's inside the denominator. So I have x plus 3, so I'm going to multiply everything by x plus 3. Now it's going to cancel out here and here. So rewriting what I have 1 plus 1 times x plus 3 over x minus 3 equals x squared minus 3 over x minus 3. So again, I still have something in the denominator. So to get rid of whatever's in the denominator, we multiply. So I'm going to multiply everything by x minus 3. And so those are going to cancel out. So now rewriting what I have, I'm going to have x plus 3, or sorry, x minus 3 times 1, which is just x minus 3, plus, and then I have x plus 3, because that's times 1, equals x squared minus 3. So I got rid of the denominator. It's all gone. It's not there anymore. Now I can just solve it like a regular equation. So because I see an x squared, I know it's going to be quadratic. And so what I need to do is I need to solve the quadratic equation. And so it's going to be the negative 3 and the positive 3 are going to cancel out. And it's going to say 2x equals x squared minus 3 minus 2x on both sides. And so I'm going to get 0 equals x squared minus 2x minus 3. I can factor that. And so that's going to factor into x minus 3 and x plus 1. So therefore x equals 3 and negative 1. Now I have to test these. Notice if I test 3 and I plug that in, 3 minus 3, 0. I get a 0 in the denominator because 0 times anything is 0. So 3 cannot be one of my solutions. Only negative 1, because if I plug in negative 1 to any of these x's, I don't get a 0 in the denominator. Someone has a question real quick. Let me answer it. Okay. Any other questions on this first section? So the idea, like I said, we're just eliminating the denominator and then solving. What I'll do is I'll just set them up. So on number 3, to set up number 3, 2x plus 17 over x plus 1. So to get rid of this denominator, you have to multiply both sides by it. So then you're going to get 2x plus 17 equals x plus 5 times x plus 1. And so then you're going to have to distribute and do all that stuff. And it's quadratic, and you're going to solve it that way. For number 4, you're going to multiply by the denominator. So you're going to multiply both sides by x cubed plus x squared minus 2x. And so those will cancel out. And so then you're going to be left with x squared minus 2x plus 1 equals x cubed plus x squared minus 2x. And you can solve it that way. And then because it is cubic, right, we're probably going to have to do p's over q's since it's a polynomial to be able to find what those solutions are. And then you have to go back through and test them. Questions on number 5. So we'll practice maybe just going over finding the descriptive material. So if I have x squared minus 2x plus 1 over, now I can start factoring this a little bit. So x times x squared plus x minus 2. So the top will factor into x minus 1 times x minus 1. The bottom will factor into x plus 2 times x minus 1. The x minus 1's cancel out, so that tells me I have a whole where x is 1. My vertical asymptotes, whatever's here in the denominator, So my vertical asymptotes, it's going to be x equals 0 and x equals -2. And then looking at the original, because the degree on the bottom is larger than the top, I have a horizontal asymptote of y equals 0. So those are the descriptive pieces, and we put all that on the graph. And then we just test values. Test lots of values. The more values you test, the better. Okay, next one. It says use the given function f to find f of 0 and solve for f of x equals 0. So I'll do number 7. So the first thing is find f of 0. That means plug in 0 for x. So f of 0 equals 2. And then the second piece is f of x equals 0. So that means I set the entire function equal to 0. And now I need to solve for x. So you can square both sides. 0 equals x plus 4. Minus 4 on both sides, you get x equals -4. Questions on that one? Okay, the next one, it says find the line parallel to the given line which passes through the point. So on number 8, y equals 3x plus 2, and my point is going to be 0, 0. So parallel means same slope. So whatever my slope is on that equation, it's going to be the same for the parallel slope. So that means my parallel slope is 0. So then my point slope equation, sure, I'll go back to number 5. So that's going to be y minus y1 equals m times x minus x1. So what I'll do is I'll finish the rest of this. I'll do one from each, and then I'll go back to number 5. So plugging in the values, I'm going to get y minus y1. So this is my x1 and this is my y1 equals my m times x minus x1. So you're going to get y equals 3x. Any questions on number 8? We'll do number 11 on this one. So for my equation y equals -6x plus 5, my point is 3, 2. So perpendicular slope means opposite reciprocal. So from -6, opposite means you flip it. Sorry, opposite means it turns positive or you change the sign. Reciprocal means you flip it. So it's going to turn into a positive 1/6. So then y minus y1 equals my m times x minus x1. Distribute that. Add 2. You know, I'm doing actually a lot of extra work that I don't really need to do. I just realized by looking back at the question. So that'll be 3/2 plus 3/2. Long story short, it just says find the line perpendicular. This could be it. It doesn't ask which type of equation, so that works. All right, so let's go back to number 5. Okay, so we have x squared minus 2x plus 1 over x cubed plus x squared minus 2x. So reevaluating that one, finding the descriptive material, if I factor everything, on the bottom it was x times x plus 2 times x minus 1. And then on top it was x minus 1 times x minus 1. So then those will cancel out. I had a whole at x equals 1. I had vertical asymptotes at x equals 0 and negative 2. And then we said that we had a horizontal asymptote at y equals 0 because the degree on the bottom is larger than the top. So now graphing this, what I want to do is I want to start labeling everything. So I have a horizontal asymptote at y equals 0. I have a vertical asymptote at x equals 0 and at x equals negative 2. So what I need to do is I need to pick points to figure out what's going on. And so creating my table, the values that look interesting to me would be values on this side of my asymptote. So that's going to be values like negative 3, negative 4. Now in between, I have negative 1, but I don't think negative 1 is going to be enough information for me. So maybe I should also do negative 1.5, negative 1, and negative 0.5. And then some values on this side of the asymptote would be like 1 and 2. Now, all we need to do is just take those values and we're going to plug them into my reduced function here. So you're going to take them and you're going to plug them in here. And then that is going to help us kind of sketch where our graph is going to be. Now, just to save some time, I'm going to just use Desmos just because I can create the table from that and then grab those values. And then we can look at the graph afterwards. But all you'd have to do is just take each value and just plug them into your calculator. So I said negative 3, negative 4, negative 1.5, negative 1, negative 0.5, 1, and 2. So at negative 3, we got negative 1.33. At negative 4, we got negative 0.625. At negative 1.5, we had 3.333. At negative 1, we got 0. And at 2, we got 0.125. Okay. So, and then, at negative 1, we got 2. I jumped ahead here. At negative 0.5, we also got 2. Then at 1, we got 0. And at 2, we got 0.125. There we go. So let me just double check all the values. Good. Negative 4. Good. Negative 1.5. Good. Negative 1. Good. Negative 0.5. Yes. 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 Okay. So, plotting these values, the first one, we have at negative 3, we said it was negative 1/3. So that's about right here. And then at negative 4, it was going to be negative 0.625. Sorry, that should be here. And that should be here. So at -3, it's -1/3. It's about right there. And then at -4, it's about right there. So that means that following the asymptotes, my graph is going to do that. Now the middle part, so at -1/2, we said it's 3.33. So that's about right there. Then at -1, it was 2. So it's about right there. And then at -1 or -0.5, it was also 2. Now, that doesn't give me much. I don't know if it's still going to go down, right? My graph could still do this. I don't know if it's going to do this. So what I should do is I should also test. That tells me, okay, I should do -0.25. So let's get even closer to 0 and test that. So if I use my calculator to say -0.25, that's going to give me 2.8 something, 2.86. So then if I were to plot that one, okay, now I know it's going to go up. So it's going to do something like this. It's not perfect, but at least I know, because I tried the -0.25, I know then it's going to go, and it's going to go back up. Then plugging the 1, we said that that's 0, and then the 2, it's going to be 0.125, which is like right above it. Okay, so that still doesn't tell me any information. I don't know if my graph is up there, if it's doing that and like that's my asymptote, or if it's down here and it crosses and that's my asymptote. I don't know that right now. Just those 2 points don't give me enough information. So maybe if I plug in 0.5, which if I plug in 0.5, that's going to give me -0.04. So if I plugged in 0.5, that gives me this value down here. So now it tells me that my graph is going to do that. But it's going to cross, but it's still going to approach the asymptote. Let me see if I can zoom in a little bit here. Now I know my graph is a little messy. This is going to go up. This is going to go up. So it's going to cross and it's going to approach. Now let's look at Desmos. So here's correct. It's matching that. There's my loop. It's going to go up. And then here's this one. It crosses that horizontal asymptote, but then it approaches it. So for sketching it, all I had to end up doing is picking more points. And this was a great, great example into just showing that those initial values wasn't enough to see where it was going. And so you just pick more points to get more precise about what's going on with the graph. Do you have any questions on that, Kira, or did that sufficiently answer it? Yay, cool. All right, anyone else with any other questions on the information? Is there anything that's restricted on this? I'm having a Did anyone have any trouble logging in to view this video? Like, did it say like you weren't able to? Okay. I'm taking the silence as you're able to. A couple of people are saying that it's like unrestricted mode, which is really weird. I don't understand. But other than that, I think we're good. If you guys come across any issues or any questions, go ahead and just post in Discord, and I'm more than happy to answer. Other than that, I will see you guys tomorrow. Have a good one.